Today we're going to go through and talk about how to solve systems of equations using elimination when we actually have to multiply one or both of the equations. They're both going to already be in standard form, so all the variables should be lined up. You'll remember from the last lesson that these 4 steps are the ones we were following. So the first one, write the system so that the like terms are aligned. That's going to be taken care of for you today. Step 2 is eliminate one of the variables. Sometimes we're going to have to do a little extra work here. Step 3 is to substitute the value back in to find the other value and then write it as an ordered pair for your solution and check your solution. So let's go ahead and get right into this. There are a couple cases. Sometimes you have to multiply one equation. Sometimes you have to multiply both equations. So when you look at these, you really need to look closely to decide, kind of like you would with the common denominator, what number do both my coefficients go into? So if I look at this, I have 10 and negative 5. How many times does 5 go into 10? It goes in twice. So what I'm going to do is I'm going to go ahead and multiply this whole equation by 2. I don't worry about signs at all until after I've multiplied, and then I decide if I need to change my signs. So we'll do that at the end. So I'm going to rewrite my first equation. It's staying the same. I'm not changing that one at all. And then the second equation, we're going to multiply everything by 2. So I get negative 10x plus 2y equals negative 36. Most common mistake that I see here is that people mess up their signs or they forget to multiply everything by 2. So they'll put a negative 18 down here instead of a negative 36. Now that I've multiplied, though, you'll notice that my x's are opposites. So I have a 10x and a negative 10x. Once I have opposites there, I can go ahead and cancel. I'm going to add them together like we did in the last lesson. I'm going to add 2y and 2y to get 4y. I'm going to add 24 and negative 36 to get negative 12. Solve for y to get negative 3. Now remember, we have to have a point for our solution. We have to have an x and a y. So right now I just have a y. I'm going to go back to one of my original equations up here, and I'm going to plug negative 3 in for my y. And I'm just going to go ahead and plug in the first one. So I have 10x plus 2 times negative 3 equals 24. I'm going to go ahead and simplify and solve. So 2 times negative 3 is negative 6. I'm going to add 6 to both sides. So I have 10x equals 30, and I'm going to divide by 10. So I find x equals 3. So my solution here should be 3, negative 3. Remember that your x and y go in an ordered pair in that order. And then I'm going to go ahead and plug these into the second equation just to make sure everything's good. So I'm going to do negative 5 times 3 plus negative 3 equals negative 1. So negative 5 times 3 is negative 15. If I add those together, I get negative 18. Okay, so since negative 18 is equal to negative 18, we're in good shape. Okay, let's go ahead and do the next problem. We're going to compare these and ask ourselves, how many times does 2 go into 14? Okay, goes in 7 times. So we're going to go ahead and multiply everything in that second equation by 7 so that we end up with a 14 up front. First equation stays the same. Second equation becomes negative 14x and then a minus 7y and 7. So remember, make sure you multiply everything in the equation by 7. So 7 times negative 2, 7 times negative 1, and 7 times 1. Now, looking at these two equations, I have opposites for my x's. 14x and negative 14x cancel. But I also have a 7y and a negative 7y. So those cancel as well. I have 0 left over. Negative 2 plus 7 gives me 5. Now, this is one of those special cases because all my variables disappeared. So since 0 is not equal to 5, I know that I have no solution. So if I looked at the graph, these would be parallel lines. So answer is no solution there. Okay, so these two, not too bad. You're going to multiply one equation by a number so that the coefficients in one of the variables are opposite. Now, it doesn't always have to be the x. Sometimes you could do the y if it's easier, but it's completely up to you. In these next two, if you look at them closely, I'm going to start the same way. I'm going to ask myself, how many times does 3 go into 4? Well, it doesn't. How many times does 3 go into 5? Well, that doesn't do that either. So now I need to think about this and decide for either one of these, what do both of those numbers go into? So I'm going to look at my x's. What do both 3 and 4 go into? They both go into 12. So if I multiply the first equation by 4 and the second equation by 3, I should get 12 for both of those. So 3x times 4 is 12x, 3y times 4 is 12y, and negative 21 times 4 is negative 84. Don't forget to multiply that number by whatever you're multiplying. Second equation, 3 times 4x is 12x. 3 times negative 5 is negative 10. And then 3 times 8 is 24. So now if I look at these closely, I'm going to compare my coefficients. I have 12x and 12x. Think back to the last lesson. Do these actually cancel? Because they're both positive, they don't. So we went through and we just changed our signs for everything in one of the equations so that they did. So I'm going to make that 12 negative, the 10 positive, the 24 negative. Now those cancel. So 12y plus 10y is 22y. And if I add negative 84 and negative 24, I get negative 108. I'm going to check here because I think I made a mistake. I did make a mistake. Right here, hopefully you caught it. 3 times 5 isn't 10, it's 15. And I caught that mistake because if I divide 108 by 22, I actually get a decimal. So that should have been a 15. So 12 plus 15 looks a little bit better. 12 plus 15, we get 27. Okay, so now 108 divided by 27 is negative 4. I apologize for that. Okay, so now that we have that answer, we're going to go ahead and plug that back in and find the next one. So I'm going to plug negative 4 in for my y, because that's what we found there. We're going to do 3x plus 3 times negative 4 equals negative 21. So 3 times negative 4 is negative 12. I'm going to go ahead and solve this. So I'm going to add 12 to both sides to get 3x equals negative 9, and then divide by 3. So my solution here should be negative 3, negative 4. I'm just going to go ahead and show my work to check this in the second equation, make sure it works out. Remember, you could always graph those two equations in Desmos and just find the point where they cross. So I'm going to do 4 times negative 3 minus 5 times negative 4 and see if that equals 8. So I get 12, negative 12 plus 20 equals 8. Since that works out, we're in good shape. So our answer is negative 3, negative 4. Okay, for B, we're going to do the same thing. Notice that 2 doesn't go into 7. 7 doesn't go into 2. So I'm going to go ahead and multiply these equations. I know that 2 times 7 is 14. So I'm going to go ahead and multiply the top equation by 2, bottom equation by 7. That way I'm closer to having my opposites. So 2 times negative 7 is negative 14. 2 times positive 7 is positive 14. And 2 times 28 is 56. So then negative 2 times 7 is negative 14. 2 times 7 is positive 14. And 7 times 8 is 56. Now hopefully you're noticing that these are exactly the same. But since these aren't opposite, I'm going to go through the process. I'm going to change this to a negative, positive, this to a negative, and that to a negative. And you're going to see that all three of those actually cancel out. So I get 0 equals 0. So remember, if my variables are canceled, they're completely canceled out, and I get something like 0 equals 0, it's true. That means I have infinitely many solutions. Whoops. Okay. Now, go ahead and try the guided practice problems. and raise your hand when you're finished. We'll check your answers and make sure you're okay with these. And then if you're good, we will give you your homework. Tomorrow, we're going to do a little bit more elimination when we have to manipulate some equations. And then Monday, we're going to talk about how to make sure we know which method might work best. So again, if you have questions, make sure you speak up, raise your hand, ask a question. If you think you've got it, let us check your guided practice problems and you can get to work on your homework.